All right, let's talk about conversions, especially when we do imperial to metric or metric to imperial, and then metric to metric. I want you to always put your answers in the SI units. SI units also is called the MKS system of units. Unless I specifically tell you otherwise, you have to make sure you report your units properly. There are only 3 countries in the world that have not adopted the metric system as their official measurement system. Those are Myanmar, Liberia, and the United States. It makes it difficult because we look at things a little bit differently and we don't have a real good handle on how the metric system goes. Occasionally, we will use the imperial system, especially in plumbing. For whatever reason, since we still use the imperial system, whenever you go to the hardware store and try to do plumbing, you will have to buy things in the imperial system. Here are the 7 quantities that define all measurements in physics and therefore science. These are the base units that we will use. In length, we use the meter, abbreviated by an M. In the imperial system, it's the foot, although sometimes you use the inch. Mass is the kilogram, abbreviated by kg. In the English or the imperial system, it's called the pound of mass, although occasionally you might use the ounce. Just as a sidelight, both ounce and inch have their same root in Latin, meaning a 16th or a 12th, depending on which system you use. Time, both the imperial and the metric use the second, abbreviated by S. In electricity, in current, you use the ampere, abbreviated by a capital A. Temperature, we use Kelvin in the SI system, Rankine in the imperial system. The amount of material you have is the mole. You should remember that from chemistry. And then luminosity, we use the candela. For the first semester, and again for most of second semester, we use only the first 4 quantities. Any physical unit that we run across will be some combination of these 7 units. Now, be fully aware there's a little bit of an exception we use in the metric system. It turns out that the base unit of mass, the gram, is too small, so we adopt the kilogram as the base unit, even though gram is the base unit. That's sometimes why the SI system is called the MKS system, that stands for mass, kilogram, and second. That's wrong. Sorry, it's not mass, kilogram, and second system. It's meter, kilogram, and second system. More on metric to metric conversions. Conversions are always going to involve multiplication or division. You can only convert between identical units. For example, you can convert between feet and meters. Both measure a length or a distance. But you cannot convert between kilograms and seconds. There's just nothing you can do that's going to convert a mass into a unit of time. And I'm not sure what that would mean anyway. Conversions always involve a conversion factor, which is always going to be mathematically equal to 1. Remember, in math, when you multiply a number by 1, you get the same number. You're just converting it from one unit to another unit. For example, we know that 1 inch is equal to 2.54 centimeters. If you divide both sides of that equation by 1 inch, you get 1 is equal to 2.54 centimeters per inch. Therefore, that conversion factor of 2.54 centimeters per inch is the same as 1. When you multiply a number by 1, you get the same answer, but in this case, it will be converted from inches to centimeters. We'll start with imperial to metric conversions. I will always give you these conversion factors. I'm not going to insist that you memorize the imperial to metric factors. Let's start with simple one-step conversions. I'll use the box method. This makes the math, I think, a lot easier. Let's convert 18.5 meters to feet. Using the table in the front of our book, I find that 1 meter is equal to 3.281 feet. This is how I would write it out. So I have 18.5 meters over 1. You don't have to put the 1 there if you don't want to. And then I have a box, and then I have my conversion factor, 3.281 feet per 1 meter. Notice mathematically I write this out so that the meters are going to cancel out. The m's cancel each other out, leaving the units of feet. Using this box method will tell you whether you have to multiply or divide by your conversion factor. In this case, to make the units cancel out, I had to multiply. Doing the math, now you have to report the number to the correct number of sig figs. I started with 18.5 meters, so that was 3 significant figures. That means my answer should have 3 significant figures. So my 60.6985 feet would get reported to 60.7 feet. The conversion factor does not matter. We consider the conversion factor to be perfect, so that the only thing that determines the number of sig figs is the number that you started with. Box method also works in more complicated units. Let's convert 70 miles per hour into meters per second. This is going to involve a box that is 2 lengths long. I write it out, 70 miles per 1 hour. My conversion factor, I have 1,609 meters per 1 mile, and then 1 hour per 300 or 3,600 seconds. Again, 2 conversions. I need to convert the numerator and then the denominator. Since miles appears in the numerator, my first conversion should have miles in the denominator, 1,609 meters per 1 mile. Hours appear in the denominator, so my conversion factor must have hours in the numerator. I know that 3,600 seconds is equal to 1 hour, so there's my conversion factor. Now I simply do the math. Notice how the units are going to cancel. Miles cancel out, hours cancel out. I'm going to be left with the correct units of meters per second. When I multiply it all out, I get 32.86111 meters per second. I started with 3 significant figures in my value, so my answer needs to have 3 significant figures. I would report my answer as 32.9 meters per second. Occasionally, conversions may involve areas or volumes. Rather than look for a specific area or volume conversion, it's often easier to perform multiple length conversions. Let's try an example. Let's convert 23.7 square feet into square meters. So I have 32.7 feet squared over 1, a conversion factor of meters to feet, 0.3084 meters per 1 foot. I proceed like before. I use a conversion factor, but this doesn't make the units work. If I do this multiplication, I would get 7.31 feet meters. This is a mixed result with respect to the units, so it can't be right. Rather, I need to do the conversion factor twice because feet squared appeared twice. So I have to have my conversion factor of 0.3084 meters per 1 foot appear twice. Now the units are going to cancel out correctly. The feet squared cancel out. I'm left with meters squared as the correct units, and then I get the correct answer of 2.25 square meters. This type of conversion will only happen with areas and volumes, so you don't have to worry about it anywhere else, but you do be aware of it. Here's a slightly more complicated example involving volumes. Let's convert 67.5 pounds per cubic foot into kilograms per cubic meter. Here's it all written out. 67.5 pounds per 1 cubic foot. Notice the feet cubed appear 3 times, so I need to have the the feet per meter appear 3 times. First, I convert pounds into kilograms. That's the first box. And then I have the 3 boxes of feet per meter. When I do all the multiplication out, I'm going to get 1,080 kilograms per meter cubed. Canceling out all the units to make sure you see where everything cancels out. I get kilograms in the numerator, meters cubed in the denominator. Area and volume conversions are very common and also very easy to get them wrong. I expect you to know how to do these and be aware that when you have areas and volumes, you have to apply the factors multiple times. Let's look at that same conversion again, but now from a mathematical point of view. This will bring up a problem that I see happen with students all the time. Order of operation becomes very important and is another place that you can sometimes make mistakes. Here it is written out again. Mathematically, to do the conversion, it looks like this. I would put this in my calculator. 67.5 times 1 times 1 times 1 times 1 divided by 1 times 2.20 times 0.03048 times 0.03048 times 0.03048. However, if you put it in your calculator like the following, you would get this wrong. Notice that you put parentheses around everything. If you put parentheses around every answer or every input, it's like putting parentheses around none of them. And you did not do the order of operation right. What this literally told you to do was take 67.5, multiply it by 1 4 times, then divide by 1, but then you're multiplying by 20 or 2.20 times 0.3048 times 0.3048 times 0.3048. You didn't do the order of operation right. Multiplication and division are equal, so without parentheses in the right places, you do them in the order as shown. Two things about this. If I ever see you use your calculator to multiply or divide by 1, I'll take away your calculator for the rest of the day. And as I said before, if you put parentheses around all the numbers, it's the same as putting them around numbers. Rather, remember the order of operations. Fractions mean do the numerator and denominator equally and at the same time. So this expression becomes this expression. Notice I got brackets around the numerator, and I have parentheses around the numerator and parentheses around the denominator. If you put it in your calculator like this, notice the difference. I only have parentheses around the top and parentheses around the bottom. When you do that correctly, you put it like this without the ones, you get the right answer. Now, imperial to metric conversions are important because we live in the United States. I will always give you those conversion factors. Metric to metric conversions are much easier. They only involve moving decimal points. The number never changes, just the location of the decimal place. So you need to know if you need to move the decimal place left or right. I'll expect you to know and memorize the metric prefixes and to do the conversions directly. All metric numbers follow the same naming methods. The first letter of the unit tells you the power of 10, and the second 1 or 2 letters tell you the specific unit. Example, kilogram. The K tells you the power of 10. In this case, 1,000. Kilo means 1,000. And the G tells you the base unit, in this case, grams. Another example would be, for example, 101.3 kilopascals. Again, the K tells you the power of the unit, this time it's 1,000 kilo, and the PA, pascals, tells you the base unit, in this case, pascals. You're supposed to only have one letter represent the unit, but pascals is an exception. Here are, from 10 to the 24th to 10 to the minus 24th, the correct prefix, the symbol, the name, and then the number that we use. These are the official ones. The ones in yellow are the ones I expect you to know and use. With only one exception, all the prefixes are powers of 3, 6, 9, or 12. Western cultures generally group their numbers by thousands. The one exception is the little c for centi. It's only used for length. We only talk about a centimeter. I think the best way to do the metric to metric conversions is to replace the appropriate prefix with the correct power of 10. Let's try an example. Let's convert 456.7 centimeters into meters. I would replace the C by the power of 10 it represents. in this case, minus 2. So 456.7 centimeters is equal to 456.7 times 10 to the minus second meters, moving the decimal places over or multiplying by 10 to the minus second, I get 4.567 meters. Going from a base unit to some metric prefix is slightly more confusing. For example, let's convert 768,560 grams to kilograms. I would use the box method. I know that kilograms are bigger than grams, so I need more grams to make a kilogram. 768,560 grams times my conversion factor of 1 kilogram per 1,000 grams. Notice more grams to make the kilogram. That moves the decimal place over to the left 3 places, so it becomes 768.560 kilograms. Metric to metric conversions are not difficult, but you have to take care to do them correctly. Unless I tell you specifically, any metric unit will be okay to use. I generally prefer that you use meters, kilograms, and seconds. Going from a non-base unit to another non-base unit just involves using 2 steps. First go to the base unit, then go to the non-base unit. For example, convert 5.67 kilometers into centimeters. First I convert kilometers to meters, the base unit. 5.67 kilometers, I replace the K with the appropriate power, that's 10 to the third, so it'll be 5.67 times 10 to the third meters, or 5,670 meters. Now I have to convert from the base, in this case meters, to the non-base unit, which is centimeters. I know that meters are bigger than centimeters, so I need more centimeters in 1 meter. Centi, the prefix, means 100. So 5,670 meters times 100 centimeters per 1 meter, I get 567,000 centimeters.